Hello everyone. Today we are going to explore one of the most fascinating circle theorems, the angle at the center theorem. This theorem reveals a special relationship between the angles in a circle. Let's start with the statement of the theorem. The angle at the center is twice the angle at the circumference when both are subtended from the same chord or same arc. First we will label the figure center O and the corners A, B, C. Theorem says if this angle is x, then this is going to be 2x. So angles towards the center is twice the angle towards the circumference from the same chord, starting from the same chord or same arc. We will be using GeoGebra to visualize the theorem. Here is GeoGebra to visualize the circle theorem. So if you see angles towards the center is 100 and angle towards the circumference is 50 from the same arc. If you draw a chord here joining these 2 points, we can say from the same chord. So it is applicable for any, if we change the shape anyway, this is applicable. So if it is 130, it is going to be half of that. So center of the angle, angles towards the center is going to be twice the angles towards the circumference. The key point is it is starting from the same chord or same arc. Now you might be wondering, why is this always true? Let me give a quick idea by proving the circle theorem. So first step, we have to annotate the figure. We will label all the corners first. Center we can give O, and all the corners we can write it as A, B, C. The first step of the proof is joining AO, joint AO. We will write the step 1, join the 2 points or join A to center. So AO. Now we will go to the second step. We identified AO is equal to OB and AO equals OC. The reason is all are radii of the same circle. So we can write the step 2, OA equals OB equals OC. The reason is radii of same circle. We have to write the reason while writing any step of the proof. Now go to the, after second step, we'll go to the third step. They are given that some angles are equal. So we are going to write the reason for that. So consider triangle. Step 3 is considering triangle in that figure. After joined A and D, we found that that figure is split into 2 triangles. So what are the properties of that 2 triangles? Triangle ABO and triangle AOC. So these 2 triangles are isosceles triangles. They are isosceles triangles. What is the property of isosceles triangles? 2 sides are equal and the base angles are equal. That is why they are given. The blue color is representing these 2 angles are equal. So we can write it out. Angle OAB is equal to angle OBA equals alpha. The reason is the base angle of isosceles triangles are equal. Now we will consider triangle AOC. The same thing we can write it here. Angle OAC is equal to angle OCA equals beta. The same reason base angles of an isosceles triangles are equal. So you have to write the reason base angles are equal for isosceles triangle. Base angles are equal. Now we will move on to step 4. We are finding the third angle of those triangles. So the angle sum property of a triangle says the angle of a triangle add up to 180. So for considering that property, we can write angle AOB, angle AOB is equal to, add these 2 angles, angle B here and angle A here, then take away from 180. So that is going to be 180 take away 2 alpha. The same way we can write angle AOC is equal to 180 take away 2 beta. Now we will move on to the 5th step. We are using another property of angle of a point. Total angle of a point is 360. So we have to take out these two angles from 360 to get the angle towards the center. So we will write it down. Step 5 is angle BOC equals angle BOC is equals 360 take away 180, so it should be there in the bracket because two terms are there, 2 alpha, and again take away, again in the bracket 180 minus 2 beta. So we have to write the reason in the bracket. Sum of the angle of a point is 360. Now we have to calculate this. That is going to be the next step. We will calculate and see is it correct or not. So we will go from this. So 360 take away 180. So it is going to be 360. Expand the bracket minus 180. Then minus to minus plus 2 alpha minus 180. Again minus to minus plus 2 beta. Here 360 take away 180 is 180. And again take away 180, it is going to be 0. So finally we will get 2 alpha plus 2 beta. So now the final step, step 6, we can write it as angle BOC is equal to 2 alpha plus 2 beta, and we can take out the common factor. So it is going to be 2 times alpha plus beta. And we consider angle BAC, angle BAC, angle BAC is equal to, that is angles towards the circumference, is going to be the total of this, that is alpha plus beta. So we can write it as, rewrite instead of alpha plus beta, we can write angle BAC. So 2 times angle BAC. So angles towards the center is BOC, that is 2 times the angles towards the circumference. That is the last final step in the proof. So we got 2 alpha plus beta, and the final step is we are adding it. So this angle is going to be alpha plus beta, and the center is 2 alpha plus beta. This is the step-by-step proof of circle theorem. Now we will do some application questions of the circle theorem. We will solve one question connected with the angle at the center theorem. Find x from the given figure. Also given angle OAB equals 40 degrees is there. So we will figure out all these from the figure, then we will start solving. So now they are given. We have to find out x, that is here, and given one angle that is OAB, that is 40 degree. So if we consider triangle OAB, triangle AB, we can write OA is equal to OB, that is radii of the same circle. Since that is radii of the same circle, these two are equal. So this triangle is triangle OAB is an isosceles triangle. So what is the property of isosceles triangle? Two sides are equal, then the base angle is also equal. So we can say that this angle ABO or OBA is also equal to 40 degrees. So we have to write it down by step. So we can write now angle AB is equals angle OBA, that is also equal to 40 degrees. We can write it as base angle of an isosceles triangle. Base angle of an isosceles triangles are equal. Now we can find out angle AOB. Angle AOB is going to be 180 take away, if we add 40 plus 40, that is, we will write it as 40 plus 40 here, that is equal to 180 take away 80 equals 100 degrees. So you have to write sum of the angles in triangle. Angles in triangle add up to 180. Now we can use the circle theorem. Since this is 100 degree, this is going to be half of that. So we can write angle ACB is equal to half of angle AOB. So that is equal to half of 100, that is 50 degrees. This is circle theorem. So angle at center theorem. So we use the circle theorem to prove this, to figure out x. So the step-by-step calculation to find x using angle at the center theorem. So we found, since this is 100, this is going to be half of 100, because angles towards the center is twice the angles towards the circumference. This is the application level of question using circle theorems. Did you know where we will use the circle theorems in real life? This theorem is used in real world designs, like constructing bridges and designing circular tracks. It helps engineers maintain the perfect proportions. So circle theorems are very useful tool while coming to constructions and all in the real life. Thank you.